Hello, everyone. Again, I'm Sergey Maschenko, SharkNet Compute Canada based at McMaster University. And today's webinar's topic is Introduction to Compute Canada, Faculty Edition. Just a bit of preliminaries. For a number of years, SharkNet has been running live new user webinars. Used to be every 2 weeks, then we made it every week. Now we run it every Tuesday at 2 p.m. Eastern Time. And we strongly recommend all users, including faculty, to attend one. And here's the link to our calendar, events calendar, where among other things, you can find registration link for the regular intro webinar. Or you can watch a recorded version of it on our YouTube channel, which is at youtube.sharknet.ca. But some time ago, we realized that we also need a customized version of this webinar specifically targeting our faculty users, whom we call PI, Principal Investigator in Compute Canada speak, because there are certain things which we never discuss in detail during our regular intro webinars. On the other hand, in a regular webinar, we go too much into technicalities which not all faculty would be interested, like how to submit jobs, things like that. So that's why this is the very first time we present our customized version of intro webinar, specifically targeting faculty users. So let's jump ahead. Here's the outline of today's presentation, which will be roughly 40-45 minutes long. And hopefully there'll be plenty of time at the end for questions and answers. Multiple staff, SharkNet staff is in attendance. So if you have any questions, they're here to answer your questions, and myself included, of course. Not exactly in this order, but today I will describe what is Compute Canada, what it can do for you, how to get help. There are multiple venues for getting help. I will discuss what kind of computing resources are available, including computing resources, storage, software, and others. And obviously, this is a faculty edition, so we'll spend some time discussing the administrative aspect of Compute Canada accounts, how to administer a research group, in particular, adding, removing students and postdocs, who owns files, and we'll discuss and end this webinar talking about resource allocation competition, which is currently underway. So the timing is very good to talk about RAC. And at the end, there will be questions and answers period. Just a brief overview of Compute Canada geography, so to speak. It, by and large, is an umbrella organization, which includes a few 4 major regions. WestGrid, we are here in Compute Ontario, also Calcul Quebec and AceNet. On a more detailed level, SAM and specifically Compute Ontario, our region consists of a few components, consortia. One of them is SharkNet, so it's us, and also SciNet and CAC and HPC for Health. As you can see, the 4 existing major national clusters, data centers, are hosted by some of these regions or consortia. Cedar is by WestGrid, Beluga is by Calcul Quebec, Graham is hosted by us, by SharkNet. It's located on Waterloo University campus, and Niagara is hosted by SciNet. So what Compute Canada can do for you? Early on, I'll start mentioning that this is all free. It's a very important aspect. So getting an account is free, and with a Compute Canada account, you gain free access to large resources available to academic researchers in Canada. That includes compute resources, CPUs, GPUs, also if you need lots of RAM, storage, cloud, virtual machines, and so on and so forth. And the idea is you need Compute Canada if what you're trying to do in your research goes beyond to what is available locally, like your desktop, your maybe small lab cluster, things like that. If what you have is too limiting, then you should not hesitate to get a Compute Canada account and try to use our resources, as I mentioned, for free. Unlike other ways you can get resources, for example, from Amazon Cloud, there is a value add-on, significant value add-on. It's expert support from Compute Canada staff. There are more than 200 of us across Canada. And probably most of us have PhDs in different areas. And we are all experts in different areas of research computing, advanced research computing. So we are here to help you, again, absolutely, for free, of course, with any issues related to using our resources. And there are multiple venues how you can get help, and I'll be discussing in more details, but that includes ticketing system, email documentation, and training events. More specifically, as a faculty user of Compute Canada, you can, and in fact should, manage your group, adding, removing students, postdocs, external collaborators, and so on. You can apply for dedicated resources, and we currently have a call now to apply. It's once a year. I'll give you more details at the end. And I also will tell you whether you need to apply or not. And with the asterisk, I'll mention in a second what that means, you can also apply for dedicated programming support. And the asterisk basically means, even though technically any faculty from Canada can apply for the last point, a preference will be given to faculty from SharkNet 19 institutions, member institutions. Of course, the first step is for you, faculty, to get Compute Canada account. Just to repeat, it's free for you and for all members of your research group. There are some official requirements, one of them to be basically a researcher from Canadian academic institution. To apply, you go to this website, ccdb.computecanada.ca, fill out the online application, submit. Typically 2 business days, someone will go through application and approve it. Who specifically depends on the region. In SharkNet, we have your peers, faculty, who are site leaders. And it's that part of their job to just basically make sure you're actually faculty at this institution, and then they approve it, and that's, you're done, basically. You have instant access to our resources. Next step, to add your students, postdocs from your research group to this account. Important point here is it's the students and postdocs who do the applying part. The only part required from you is to go to CCDB and look up your Compute Canada role ID, which is we called CCRI, and it looks something like this: 3 letters dash 3 digits dash 2 digits. So you give it to your students, postdocs, and then them have to go to the same website, CCDB, fill out the application. They should make sure they identify themselves as a sponsored user, not as a faculty user, and specifically either graduate, student, or postdoc, and so on. Very critically, they type in your CCRI identifier and then hit submit. And now it's your task to approve them. No one else would be approving it. It's your task. So you should be receiving email shortly. Quite often it goes to spam box. So please make sure you check and double check your spam box within, a day or 2 after they submitted the application. So please look for this email. There is a link, you click on it, you confirm this person is indeed your member of your research group, and almost instantly they get Compute Canada account, they can start using our resources. So where to get help? It used to be a lot of information was hosted on our own portal, sharknet.ca. I'll mention in a minute what it is still can be used for. But for now, pretty much all help you need should be obtained on the national site, which is docs.computecanada.ca. So regarding the sharknet.ca, I want to briefly switch to my web browser. So this is the Shark portal. You'll see multiple things here. For example, our events calendar is displayed on the front page. There is some news and highlight, but the main point here is support training. So that's where you find the detailed events calendar. So now our regular new user webinars are listed here, January interest webinars, summer schools, and so on are listed here. And also another important thing is to see a summer school page description. Every summer we run summer schools for researcher students. This year, because of pandemic, it was online, but normally it is on some sites. And our YouTube channel, youtube.sharknet.ca, which hosts hundreds of webinar recordings, tutorials, lots of useful information. So for Compute Canada users. Regarding the Compute Canada documentation site, docs.computecanada.ca, it's a wiki portal. So in principle, anyone can contribute to it. But you can also use like any other wiki portal. You can search for specific pages, or you can just browse through categories. There are things useful to beginners. There is very detailed description how to use scheduler, a list of available software. I'll get to that later. Storage, all the details you need to know. So in all the details is described in these wiki pages. Specific software packages often have their dedicated pages. Like for example, ANSYS, it's a commercial package. You just search and it gives you this very long page describing everything, how to license it. So all the details can be found here. Not all packages have dedicated pages, but ever increasing number are. So basically almost anything you need to find documentation on should be searched on our national site, docs.computacanada.ca. SharkNet web portal is primarily for training related things. So I already mentioned our events calendar. What we do regularly, new user webinar every Tuesday at 2 p.m. And here you can find registration links. Bi-weekly general interest webinars, highly recommended, delivered by our staff on all kinds of topics of interest to our research user base. So please check regularly our upcoming webinars. And all the prior webinar recordings can be found on our YouTube channel. Other ways to get help. So let's say you check our documentation site or either got overwhelmed, some pages quite detailed, or you didn't find an answer, then by far the best and the most convenient and the most efficient way to get help in Compute Canada is by sending an email to support@computacanada.ca. This will automatically insert a ticket on your behalf in our ticketing system. You're not prohibited and you're totally fine to send direct emails to staff. You can find, for example, our directory in our web portal. In the past, before pandemic, you could call us in the office or do an office visit, but obviously this doesn't work now. But the ticketing system is by far preferred way to get help because this will be assigned to the staff who is the most available and is the most expert in this particular issue. And most of problems are resolved within 24 hours or so. So it's really the best way to get help. But please just make sure when you send this email, fill out the subject line, provide description of your problem, and provide as much details as you think is necessary in the body of the email. And within a few hours, one of our staff will be assigned to it, talking to you back if he or she needs more information. And as I said, most of problems are resolved quite quickly, a day or so. And what you can discuss in these tickets, pretty much anything involving Compute Canada, like using of system, installation of software, debugging, programming, optimizing, how to use commercial software, how to set up licenses, programming, rack application. So anything which involves Compute Canada is perfectly fine subject for a ticket. Now switching to resources. What resources are available? We used to have a fairly large number of systems. We have consolidated. Now we are pretty much down to 4 national systems. We may add other national systems later, but for now, these are the 4. These are the full internet address of each of them. So if you want to log in, that's what you're gonna use. Name of the cluster .computacanada.ca. 3 of these systems are general purpose: Cedar, Graham, Beluga. Cedar is WestGrid, Graham is SharkNet, and Beluga is Calcul Quebec. And these are the systems immediately available after you or your students get an account. There is no extra steps to take. Niagara is a bit special, operated by Cynet. These are for large parallel jobs only. And Cynet does require you to send them an email asking for access. So even though the authentication is identical, the same login name, which is your Compute Canada login name, the same password, only Niagara still requires 1 extra step, but then you can use the same credentials to log into any of the 4 systems. We also have cloud services. These are primarily for things like research portals, like you need to run a web server which access some computing, but is accessible to at large to researchers in the world. Our regular clusters do not give you this ability, but cloud services are there in part to achieve this, but also any other usage, cloud usage which is relevant to your research can be done within Compute Canada. How much resource we have? It's ever increasing numbers, so we keep adding, expanding our clusters. Currently, we provide access to almost 300,000 CPU cores across all the systems. Almost 3,000 more than research-grade GPUs, which are like P100, V100, also some T-rings and Amperes are coming, the newest generation. For those who if you need lots of RAM, the total amount of RAM across all the system is more than 1 petabyte, which is quite impressive. So if you do distributed computing with MPI, it's quite realistic to gain access to tens of terabytes of RAM for, in this MPI environment. But if you do something within a single computer, single compute node, we have nodes with up to 3 terabytes of RAM. So that's what you can fit within a single computer if you need to. In terms of total file storage, is around 70 petabyte. We also have quite a bit of storage off-site, tape-based storage. I'll mention that later. Just briefly, a few words about software packages available. The best way to search for packages available is to go to docs.computecanada.ca, and there is a software page which lists many hundreds of software packages available. And the beauty of these packages, they are identically available on our national system. So any package you use on Cedar will be available on Graham. There are just very few exceptions, but otherwise this is the rule. If you don't find the package you need in our official software list, don't despair. We submit a ticket and we either help you to install it for you and your group, or if it's a fairly popular package, we can install it for all national site. Just be aware the latter process takes a bit longer, can take a few weeks. But if you need instant access, we can just install it for you, no problem. If you're already on a system, you should be aware that very few packages are instantly available, and which ones you can acquire with module avail command. But you can also search for other packages you can load optionally with module spider and then keyword. And it's sort of Google search for our module system, software system. And then it gives you a list of software packages and different versions. We often typically have multiple versions of the same package, and then you choose which one to load. So again, by default, practically nothing is loaded, but you can search, find specific versions, and then you can load them. For more details about module command sets, check the documentation side, because there are many more things you can do with module commands to make your life easier. A few words about file storage. There are a few kinds of storage on each cluster, and please be aware, these are all separate file systems. Each cluster has its own home, its own project storage, its own Scratch and Nearline. So these are totally unrelated. But all the clusters are connected through super fast 100 gigabit per second dedicated network. So it shouldn't be a problem to move things back and forth between different clusters. So when you log into a system, you find yourself inside a very small home file system, which is not high performance. So basically use it for things like source files, some small text files. You don't normally use it to run jobs. To run jobs, you typically use project file space, and symbolic links to other file systems are conveniently located inside your home default file system. So from home, you can CD to projects. As a PI, you will see a few subfolders in project file system. Project overall gives you access to 1 terabyte per group, but by request can be increased to 10 terabyte for the whole research group. If you need more, you have to apply for rack. I'll mention that later at the end. As a PI, you have access to your own space and your space where your students will find their project file space. So all your research group will be sharing your project file space. If you get a rack award, then you might see other project subdirectories where the rack specific stuff should go. Project is fully backed up, so it's safe. If something goes wrong, we should be able to recover the files for you. But it does have this limit, either 1 or 10 terabyte per group. If you need more space, you can use Scratch file system, again, conveniently accessible from your home through a symlink, up to 20 terabyte per user. But be aware there is no backups and only 60 days expire, and then it's automatically deleted. So please make sure to move away anything important from scratch elsewhere. And there is also a nearline tape storage. The amount depends on the site. Most of sites have 2 terabyte limit. If you need more, again, you need rack. I believe Beluga has even lower 1 terabyte. So that's why the asterisk is here. Ownership point will be discussed slightly later. In fact, on this slide. So as a PI, as a head of your research group, it's important to understand who owns files, both in legal terms and in operational system terms. So in principle, the generic principle is if you created a file, whether a student or PI, you are the one who owns the file, and anyone else has to ask your permission for consent to use this data. But please check with your home institution, because it is the home institution legal policies which govern the data generated by research. In this case, there is no Compute Canada or SharkNet legal procedures or rules for this. It's your home institution which governs the legalities of who owns the files, who owns the data. So please go and check with your home institution. In terms of operational system, which is Linux terms, situation is much more straightforward. All newly created files are owned by the owner, obviously. And by default, the owner has write permit and read permit, of course. The rest of the group, including PI, only have read permits. The default behavior can be changed, modified by using umask command in your bash RC file somewhere. When you log in, it's executed. So you can maybe make a particular user, a particular student can decide to make all his or her files write permission to the rest of the group. So it's possible to do using umask commands. You can modify default behavior. For files which already exist, whether newly created or old, you can modify, make them more or less permissive using a change mod command, or you can make per user modifications. Let's say you can add read permit to anyone with Compute Canada account, not even member of your group, using this set facl command. I don't have time to go into details, but docs.computecanada.ca describes all the details how to do that. A common issue is you submit jobs, or your students submit jobs, and you feel you wait too long in queue, because we have scheduler. You can't just run your jobs instantly. You submit to the scheduler, and then you end up waiting days, maybe in worst case scenarios. So what can we do? Quite often, this long wait time is due to the job, as we say, incorrectly shaped, or in other words, the job asks for too much resources, more than it actually needs, in terms of runtime, in terms of memory it needs, in terms of CPU cores it needs, or number of GPUs it needs. So what we can do, we can try to analyze the job which waits too long and maybe suggest that it asks for too much memory, which can be quite expensive. Once you go beyond 4 GB of RAM per CPU core, your queue wait time becomes significantly larger. So you really want to make sure you actually need more than 4 GB of RAM per core. Same goes with the runtime and number of CPU cores. What we cannot do is we cannot manually start jobs which have been waiting in queue because they're incorrectly specified. So because it really breaks our scheduler, so we don't do that. What you can do, you can use our documentations, watch our webinars to educate yourselves and your group members to basically to learn how to shape your jobs properly, so they ask only for resources they need, and so they don't wait in queue unnecessarily. But you just have to be aware that 80% plus of resources of cycles on our clusters are allocated through rack process. More about that later. So if your job waits in queue too long, maybe you need to apply for rack. Maybe this is the ultimate solution you and your research group members need if it becomes a really persistent problem. More about that later. So in fact, I'm switching, I believe, to the 2 or 3 final slides dedicated to rack. So what is rack, and do you need one? Rack stands for Resource Allocation Competition. And you need to apply for one if you expect your group to need more than the default amount of resources in the next year. And for RAC, year starts on April 1st. So application is once a year, as mentioned here in the fall. So we already made a call for applications. You can apply now, and there will be a few weeks before the deadline, but you can start applying now. And basically you have to figure out, do you and your research group, does it need more than the default amount of resources for the year, which starts next April and goes to April of the following year? And currently the default resources are 50 CPU cores, 10 GPU years, 10 terabytes of storage. So if you go over any of these requirements, you should be applying for RAC. And RAC, it's a real application where you have to provide scientific justification and technical justification. There will be a peer scientific review, and based on merits of your scientific merits of your application, you may get better or worse sort of a score, and then you either can get almost or everything you ask for, or sometimes you get less than what you ask for, because it's highly competitive. We have lots of researchers applying for RAC. And as I mentioned, 80+% of our cycles are allocated through RAC. So yeah, basically a lot of consideration is given to scientific merits, as also technical consideration given. So who can apply? Only the PI, the faculty, can apply for RAC. And in a more specific level, only the person who would be allowed to apply for like an answer for Canadian granting applications, research application, would also be allowed to apply for RAC. So just to be aware. So all the details can be found on the RAC page of Compute Canada documentation site. You have to be aware that what RAC does or what it doesn't. So it does increase or give you priority, rather, access to CPUs, GPUs, up to a prescribed amount you ask for, or you were allocated for the whole year. It gives you exclusive access to storage if you get storage through RAC, or if you get VMs in our cloud, you get exclusive access to VMs to run portals. But what RAC cannot do, it doesn't do, it does not take resources you ask for out of the cluster and give you exclusive access to those compute resources. No, you cannot. We cannot do that. It just increases priority for your jobs. You still have to wait in queue. And remember, you're competing mostly not against default users. There are fewer than 20% of the jobs are default. You're competing against other RAC users. There are 80+% of cycles consumed by RAC users. And so a strong advice suggestion here, you're asking for resources for the whole year. Let's say you need 100 CPU core years for your whole research group for 1 year. Please think carefully how you're gonna span it, what's the pattern. Just imagine there are 80+% of other jobs are also RAC, so you're actually competing against them, even though your priority is higher than default priority, but mostly you're competing against other RAC usage. So if you plan to consume all your resource in a huge burst last week before deadlines, think again, because chances are you won't be able to consume all the resources you asked for. Try to spread it out, distribute it, maybe a few bursts, not one ginormous burst at the end, because you won't be able to consume very quickly in a single burst. So please give it a consideration. Don't sort of end up in a situation that you have deadlines and then you just cannot consume resources you asked for because you waited until the very end. And a couple of technical things related to RAC. So you are RAC administrator, you're PI. So what you can do, you can log into CCDB website, and then you can manage membership of your RAC. So by default, all your group members are RAC members. If you get awarded a RAC award, by default, all your group members will have access to RAC. If you want to limit that to fewer people, to those who actually participate in your RAC, then you should do it by steps specified here, going to this website, clicking on Manage RAC Membership, and then modifying or removing the other students or postdocs if you don't want them to be a member of your RAC. You can also promote any other group member to be manager to do these administrative tasks. And just to make it more visual, I don't know if you can read the text, but that's where you go to your RAP details. Then you click Manage RAP Membership, and that's where you manage individual users' access to RAP. And I believe that concludes my webinar presentation. Thank you very much for your attention.